In today's digital age, where mass data is king, more and more new data applications are emerging, driven by new technologies from high-performance computing, HPC for short, to big data analytics and artificial intelligence, or AI. During the ongoing research and development of autonomous driving, for example, hundreds of petabytes of AI-trained data needs to be stored for several decades. Elsewhere, in a smart factory, 1 petabyte of production data is generated in just a single day. And in AI-driven drug discovery, a sequencer might generate 6 terabytes of data per day. It's clear, the HPC industry is evolving from computing-intensive to data-intensive, with high-performance data analytics, or HPDA, emerging as a clear trend, which is why it's sometimes used to refer to HPC. Let's take a look at a more detailed example. In the process of genomic analysis, there are many performance and access needs to consider, such as the processing of different sized files, different response latencies, and multi-protocol access, such as NFS for standard file access, MPI-I/O for parallel access, HDFS for big data analytics, and S3 for data archiving. In these cases, the term hybrid is used to describe typical characteristics. For example, a hybrid performance model or a hybrid multi-protocol access mode. For these new workload service flows, an all-in-one storage system is ideal. So, this emerging topic in the storage field is asking the question, how can mass data be efficiently analyzed to unleash its full value, which is purpose-built for emerging applications, including its SmartBalance system, designed for hybrid workloads. Huawei's SmartBalance intelligently senses data types and I/O flows to effectively improve hybrid workload efficiency, adopting 3 groundbreaking innovations. The first of these is multi-protocol capability balancing, which enables native and seamless interworking between file, object, and HDFS storage protocols. Next, with dynamic resource scheduling balancing, data flows adapt to large and small I/Os, achieving optimal bandwidth, IOPS, and OPS performance. Finally, large and small I/O path balancing achieves optimal latency and disk utilization. Let's take a deeper look into multi-protocol capability balancing. While traditional object storage systems use a flat indexing structure, which enables a single bucket to support hundreds of billions of objects, traditional file systems use a tree indexing structure. This helps file management but limits the number of files a single directory can support. Traditional multi-protocol interworking is implemented based on file or object storage, using gateways and plugins to support other types of protocols. In contrast, OceanStor Pacific has designed converged indexing for unstructured data so that it benefits from the advantages of both file and object protocols. The tree structure is predominantly used, with metadata stored in lexicographical order in an ultra-large directory that's divided into multiple inner directories, single-layer index slices that are invisible to external systems. The structure inherits excellent single-bucket scalability and provides high performance and low latency for data access. In addition, single-layer index slices support the multi-part upload of objects and allow the file service to access multiple parts of a file without needing to modify upper layer applications. All this is achieved without using any physical or logical gateway, and without any function or performance loss either. What about dynamic resource scheduling balancing? As we've already mentioned, hybrid workloads come with various I/O models, such as large files with large I/Os, large files with small I/Os, and small files with small I/Os. As data flows adapt to large and small I/Os, Achieving optimal bandwidth, IOPS, and OPS performance requires dynamic resource adjustment and full balancing. Let's first look at the dynamic allocation of CPU resources. As we all know, CPUs are grouped and divided into cores. They are grouped first, and fixed service cores are bound to ensure the processing delay of key services. Then, the number of packet cores is dynamically adjusted based on the IOPS and bandwidth-based service load to ensure an optimal CPU resource ratio under mixed loads. Intelligent CPU scheduling and the separation of large and small I/O request queues reduce the CPU switchover delay. In addition, intelligent I/O scheduling ensures the I/O priority of data read, data write, and advanced features, maintaining stable latency for mission-critical applications. The result of all this means that IOPS and bandwidth performance SLAs under mixed loads are guaranteed. Finally, we come to large and small I/O path balancing. During I/O processing, OceanStor Pacific processes large and small I/Os separately. Large I/Os are passed from clients to disks, reducing path overheads, whereas small I/Os are aggregated at the cache layer and then written to disks, greatly decreasing the number of I/O interactions. Based on intelligent stripe aggregation, a large number of random write I/Os are aggregated into 100% sequential write I/Os before being written to disks, reducing the strip overhead of disks. In contrast to traditional small I/O aggregation, OceanStor Pacific implements data mirroring based on one-way RDMA to ensure the reliability of I/O aggregation. Only the primary storage node is involved in data copying between CPUs and memory. Compared with traditional cache mirroring, OceanStor Pacific further reduces the CPU overhead by 30%, improving IOPS while ensuring low latency. In terms of data read, a data prefetch design with intelligent sensing capabilities reads a large file through consecutive IOs and prefetches small files to a high-speed cache, significantly boosting data access efficiency. Put simply, Huawei OceanStor Pacific storage provides high-performance and multi-protocol access for hybrid workloads. By using converged indexing for unstructured data, it enables native, seamless interworking between file, object, and HDFS storage protocols. And by adapting data flows to large and small I/Os, optimal bandwidth, IOPS, and OPS performance is achieved. In short, OceanStor Pacific SmartBalance is a fully balanced system design. Thank you.